Okay, let's make a start. So thank you all for coming. As you should have seen on Facebook, this is actually the final session that we're doing this term. So next term, we're going to be running a kind of intro to machine learning session, which will probably be less programming because it's a big field in computer science, and you can't just kind of start out from beginner level. But we're going to get a lecturer in from the department that's actually an expert in machine learning, because I know virtually nothing machine learning wise. So instead, they will come in and do a kind of introduction talk. So you've got two options tonight. Either you can stay down here where you are and run through with my content, or you can go and do almost exactly the same content upstairs with Sion. So if you've been in his session previously, you might want to go back to him. And he's going to be covering some image processing stuff at the very end that I'm just going to kind of walk past. So if you want to do that now, feel free to leave. I won't be offended. Okay, so just as a reminder, this is the URL that you can go to, which has all the resources on, and we'll be going back to that later in today's session. So I ended last week's session by looking at dictionaries, which I described as a data structure that allow you to map from one set of values to another set of values. So we saw lists previously are literally just kind of an ordered list of values. So you can have a list of words, for example, or a list of numbers, and we did a load of exercises with them. And this week we're going to be looking at dictionaries instead that allow you to map from a string to a string, for example. So the word dictionary literally comes from dictionaries themselves, because in a dictionary you map from a word to the definition of the word, or the several definitions of the word. So we're going to start out by just kind of walking through another simple dictionary exercise that some of you may have done. Did anyone do the dictionary exercise from the end of last week's notes? Okay, that's great then. So we're going to create a new variable called d, and that's going to store our dictionary in. And to create a new dictionary in Python, you just use two curly brackets like this. So a list was two square brackets, but a dictionary is two curly brackets. And then if we want to put an entry into the dictionary, we don't have to do a kind of append onto the end of the dictionary. We can just insert wherever we like, and Python will manage it for us. So in this case, we just write this, and I'm just going to map this to aardvark, for example. So what this does inside the dictionary is map the key A, so the string A, to the string aardvark. And we can go through for a few more examples, but it's not super important what you write here. I can't spell. Just going to leave it and roll with it. Okay. So this dictionary now contains 3 entries, and we can iterate through all of the keys in the dictionary. So that's going to be A, B, and C by using the for loop that we've seen already for lists. So I'm just going to say for k in D, so for key in the dictionary. Let's just print out the key. And I will save this and run it. Okay, so that just printed out A, B, C. And then if I want to print out the values of that, I then have to do an access like this. So for lists, you'll recall that we could kind of access the ith element of a list by using this square bracket notation. So you would do x is square brackets I to get the ith element of the list. It's exactly the same for dictionary. So in this case, we're going to get the element from the dictionary that corresponds to the key k. So first, it will print aardvark, because that's the value that's mapped to by A. Then it will print bavaja, because that's the value mapped to by B, and then cat for C. So I'm just going to run that again. And that's exactly what happens. So there's another way that we could write this program, just as a kind of shorthand notation. So you remember for lists that we could initialize it as an empty list, or it's just 2 square brackets, or initialize it as curly brackets and then a list of all the things. And we can do roughly the same for dictionaries. So if I want to just map A to aardvark, I can type it like this. And then I can write, so you write a colon to separate the key from the value. And then I could also map B to, let's get this right this time, badger. And then you'll see if I just delete these 2 lines and run the program again, it does exactly the same thing as before. So you'll notice that we have a couple of extra volunteers this week. So this is Robbie and Maria from NSoft. And NSoft is one of CompSoc's sponsors. And they very kindly donated some of their time to come and help out with us. They've also donated a lot of chocolate. I was thinking I could just chuck it at anyone when they kind of give an interesting question, but in reality, like, if you just come up when we're doing exercise or something and grab some, that's fine. Just don't eat all of it. I need some. We're going to move on to an exercise now, looking at how we can use dictionaries for doing word counting. So, for example, you take a piece of text and you count the occurrences of each word in the text. So if you had kind of two these in the sentence, we would want to print out that there are two these in the sentence. So just to kind of help you get started with that, there's a few things that you need to consider. So if you get a piece of text from the user, let's just put it in a variable called text. You remember that we had to use the input function. So I'm just going to write this. And then to get the words from that function, we're just going to take a very simple approach and split on every space. So this won't account for stuff like punctuation, for example. So if there's a full stop at the end of the word, then it will count the full stop as part of the word. So I'm just going to write words equals text.split and say that we're going to split on a space. So then, for example, I can iterate through all of the words and print out the word. Or, for example, I could type in something a bit longer. And you'll see that it prints out each word. So we're going to create a dictionary called WC. So it's going to be an empty dictionary initially. And inside this loop, you need to use some logic to count the occurrences of each word. So you need to map a word, so that's going to be the key, to a number. So that's the number of times that it occurs. And then finally at the bottom, I'm just going to write this part for you. So for word in word counts, we print out the word plus a space, and then we're going to print out the count of the word. So that's going to be whatever's mapped to by the dictionary. And just remember as well that because the thing that's in the dictionary is a number, you need to convert it to a string. So we use the string function for that. Okay, I'm going to walk through the solution now, because I'm quite keen to move on to the next exercise, because I think it's a bit more interesting. So in this loop, we get each word on each iteration. So we saw something a bit longer, for example, before. So we just need to kind of increment a counter for each word, and that's what's stored in the dictionary. So initially, you might think that you can kind of just write this. So the entry for the word, we're going to update it. So we're going to write this. It's just this plus 1. So that's all we're really doing. We're updating the number that is mapped to by the word by 1 on each iteration. So if I save this and run it, and type something like this, that's actually an error. And the problem here is that when we go on that first iteration of the loop, so word is something, well, there's nothing stored in the dictionary for something. So when it's going over here on the right-hand side for getting what was there already, it just gets none back, and that's where we see this error come out. So you actually have to handle this as a kind of special case. So if we see a word for the first time, then that means word is not in WC. So we write this. And in this case, we just have to set it to be 1, because we know in this case that we've only seen the word once. And then we just kind of do an else case for this. And remember that we have to indent it because it's inside the else statement. So now if I save it and run it, and enter this text, you see that you get the counts out. So each word has only occurred once in this sentence. So now if I run this and actually repeat a word, so the cats ran down the road, well, the comes out twice, so it counts that word twice. So that's all there is to this program. And we're actually going to kind of move on to looking at our third and final data structure of this course. So we've seen strings and numbers originally. Then we moved on to looking at lists and dictionaries. And the final one that I want to look at is stacks. So a stack is a lot like a real life stack. So you can put things onto the top of the stack and put more things on the top of the stack. But you can only ever remove things from the top. And we call that operation removing from the top popping. So we push onto the top of the stack and we pop off the top of the stack. Conversely, you have queues where you push onto the end and you dequeue from the very front, because the person that was there first is the first person to leave the queue. But we're only going to look at stacks in today's session. The way that stacks work in Python is exactly the same way that a list works, and in fact, they are just lists. So I'm going to declare so this is a new file, and I'm going to declare a stack variable that's just called stack. And if we want to push onto the end of the stack, or push onto the top of the stack, we just use the list append method. So this is literally just a list, so I can write stack.append 1, say, then stack.append 2. So although this is a list, we're actually going to be thinking about it as a stack. So initially there is 1 on the stack, and then we push 2 onto the stack. And we want to be able to pop things off of the stack, and we use the pop method to do that. So what this will do is pop off 2 from the stack. So it will remove 2 and keep the 1 in place. So at the end of this program, we will have printed out 2 and just left 1 on the stack to do nothing. So I'm just going to save this and run it. And that's exactly what happens. And these two operations are incredibly important, and I'm going to explain in a moment how stacks are really widely used in programming. And your computer is probably doing millions of operations on stacks every single second. That's how important they are in programming in general. So we're going to look at something called stack machines. And Python itself is actually just a virtual stack machine. So in our stack machine, we're going to have a series of different operations of things that we can push onto the stack and ways that we can remove things from the stack. And I'm just going to run through a simple example. Pushing a number onto the stack. So we push 20 onto the stack. And then we might push 10 onto the stack. And then we have an add operation. And what the add operation is going to do is pop the 2 top elements from the stack and then push their result back onto the stack. So after it does this, it's going to remove 10 and 20 and push 30 onto here. Then, for example, we could then have another instruction that pushes 10 onto the stack, and another one that pushes 20 onto the stack. And then we add 10 and 20 together because they're the top 2 elements of the stack, those last 2 elements. So that will pop off the result and push on 30. And then we might do a multiplication operation. So that pops off the top 2 elements. That's just 30 and 30 in this case. So it's popping the one on the right first and then the one on the left. And then it pushes the result 900 on. And this probably seems a bit abstract at the moment, but this is exactly how Python computes expressions. So when you write something like a times b plus c, what Python will do is push b onto its internal stack, then multiply them. So it pops 2 off and then pushes the result back on. Then you push c onto the stack, and then it sees the add operation, so it adds the result back on. So what we're going to do is write a very simple Python program that takes a series of instructions like this in a list, and then it's going to execute them on the stack. So it, either push on numbers or, based on some operation, pop off the result, pop off 2 numbers, and then push the result on. So I'm just going to kind of start out by giving you a framework for this. So we're going to take a list of instructions, and we're just going to hard code this in. We're not going to take this as user input for now. So let's just say, we start out with that example I had at the beginning. So 10, 20, and then we're just going to represent our operations by strings. So the way that we'll interpret this is push on 10, push on 20, then pop off those 2 from the top, add them together, and push on the result. So we're going to iterate through each instruction. So I'm just going to write for instra, that's short for instruction, in instructions. And if we see that we've been given a particular instruction, we're going to do the operation for it. So in the case of add, I'm going to write if instra equals this. So this will only be true for the last element. We need to pop off the top thing from the stack, then pop off the second thing from the stack, and then we're going to push on the result of the 2 of them. But if it's just a number, then we just need to push the number onto the stack. So that's going to cover the other case. So as we loop around this, initially we get the 10, and it falls through to the else statement because it's not equal to plus. And so it appends 10 onto the end of the stack. Then for 20, it does exactly the same thing. So the stack is then 20 at the top and then 10. Then it sees the plus, and it pops off those 2, and then pushes the result back on. So in the final state, we should see 30. So at the very end, we're just going to print out the state of the stack. So this will be the list of all the things that are on the stack from bottom to top. So it just prints 30. So what you're going to do is just add support for a few more operations. So for example, you might want subtraction, division, multiplication. And it should be reasonably intuitive because you're just kind of replicating those first 4 lines and adapting the operation in each case. And then you just need to write a longer series of instructions. So maybe do 10, 20, 30, plus, plus, and see what that produces. And then I'll move on to explaining why this is relevant to Python, and then wrap up the session with an exploration of other things that you can do with Python and what's interesting to do after this course. And again, feel free to grab more chocolate. So I'm just going to add multiplication onto mine, just so you can copy something. So hopefully that will give you the opportunity to kind of figure out a few more operations. So as you can see, I've added an extra kind of operator on here, an extra instruction, that takes 2 things off of the stack and computes the maximum of the 2 numbers and pushes the result back onto the stack. And if you kind of expand this out, you can see how you could start implementing Python functions like this. So there is a max function in Python, for example, that takes 2 numbers and then returns the maximum of those 2 numbers. And internally, that's exactly how Python's working. It pushes on the 2 arguments of the max function onto the stack, and then the max function executes and goes and pops those 2 off, and then puts the result back onto the stack. So internally, this is very much how Python works. And so this broad topic of stack machines is actually very near and dear to my heart, because over the last 6 months, I've basically implemented something that looks exactly like this. For my dissertation, I've implemented this, but executing somewhat faster than what Python can do, but on a computer that costs kind of way under $1. So they've actually been dished out to nearly every school kid in year 7 in the country. So that's why we're kind of having a look at it, and also why stacks are very useful in computer science. So I want to wrap up both today's session and the course by showing you just a few other places that you can access Python resources. So let's just get to the end of this. Obviously, this will remain available, and nothing on the GitHub will change until next year when the course starts again. And there will be a copy of it that's available that's like in its current state. So if you want to look back at any of the sessions, you can go to this URL, and it's got full descriptions of everything that we did, all the exercises, all the solutions to the exercises. There's also videos if you want to kind of spend your afternoons listening to me. And then the Python website itself is absolutely fantastic. So we haven't encouraged you to explore it too much. But if there's any Python syntax you don't understand, it's all very, very well documented there. They also have documentation for literally every function in Python. So if there's anything that you need to look up, you can see how many arguments it takes, what order the arguments have to go in, and what it will return under certain conditions. So that should kind of become your Bible for Python programming, I think. Then there's this really good online book, and it's called Learn Python the Hard Way. And it was what the course was based on last year, but we've kind of eased up a little bit this year. But this is a really good introduction to Python itself. So you can probably skip through the first few chapters because you will have seen it already. But there's like 30 chapters to this. So it would be what this course was if I was running it all year and had infinite free time. If you want to kind of explore more programming exercises, this isn't so much Python-specific stuff, but just kind of getting better at computational thinking and problem solving. There's this site called projecteuler.net that has kind of on the order of 300-400 problems on it that you can work through. And they start out kind of fairly straightforward, definitely stuff that we've covered in this course so far. But then when you get to the 20th problem, you'll probably kind of be seeing maybe maths you haven't necessarily seen before or CS concepts you haven't seen before. And something that's really important for Project Euler problems is to get them executing quickly. So the idea is your program has to run in less than 5 seconds. And often for these problems, you can execute a solution that will run in a minute, say. But there's actually a way of writing it a lot more efficiently that will kind of execute in fractions of a second. And they really emphasize that, which I think is really useful. Who's a scientist in the room? Okay. So these two are particularly relevant to you guys then. So these are 2 Python libraries. This is sets of Python code that you can go and download and use in your Python programs. So NumPy and SciPy. And they're really useful for like big data processing. So if you've got data from an experiment and there's things that you need, analysis that you need to do that you could do in Excel, say, but that is kind of tedious, then these kind of libraries are really, really useful for automating some of that process, or maybe gaining insights that you wouldn't be able to get through Excel itself. Furthermore, has anyone used R for statistics stuff? Okay. So hopefully some of the Python concepts that you've seen in this course will map over to R quite well. I'm not super familiar with R, but if you kind of look back at it now, you should hopefully be able to find a lot of similarities. And there's tons of great R resources available both online and within the university itself. For those of you that are interested in machine learning, we would have covered this at some point. TensorFlow is one of the most popular libraries for machine learning. Well, pretty much all of Google's machine learning projects that I'm aware of use TensorFlow in some way. So when you kind of upload an image onto Google and it kind of figures out there's a cat in it and a bunch of people or whatever, it's all running through TensorFlow. So it's a really, really powerful library. And Google has made it freely available. So you can go and download that and run that on your computer and build machine learning models. If you're more interested in image analysis, and Scion actually has some demos of this, so if you want to go upstairs, you can have a look at this. There's another library called OpenCV that is able to take images and run machine learning kind of tasks through them. So he's got a demo where he can kind of pick out somebody's face or somebody's hands or whatever. And you only have to write maybe 10, 20 lines of code to do that. And obviously, it's kind of then accessing millions of lines of code within OpenCV itself. But that's a really great project, and it's not too inaccessible. So we really encourage you to go and have a look at that as well. So has anyone seen Khan Academy for stuff other than computer science before? It's fantastic for computer science these days as well. And they have on the order of kind of like 400 videos or something, and exercises that you can work through. So they have a mixture of both Python stuff, but they've also got quite a lot of web development stuff. So if you're interested in learning JavaScript, which is a language that's quite a lot like Python, except that it executes in your browser and on every web page that you'll access will almost certainly include a little bit of JavaScript. So if you want to look at web development, then Khan Academy is a fantastic resource. And finally, within the university itself, obviously we're a great resource. We run events, like 2 events a week usually. So we run both tech talks and social events. And at any of those events, there'll be a whole bunch of people that have been programming for years, and you can go and just chat to them, and they're more than willing to help out with your problems. So if you've got something in Python you want to have a look at, or MATLAB or R, there'll be somebody there that has seen it before, and we're always happy to help. There's also CodeSoc, which do a similar kind of thing, and they have more structured teaching as well as social events. So they have a mixture of the two. Has anyone gone to a CodeSoc event, actually? Okay, well, they're fantastic, and there's a link to their Facebook page on our GitHub page as well. And finally, there's the Oxford Women in Computer Science Society. Run talks on a weekly basis as well as social events and stuff. And they also work with a lot of the other women in STEM societies to run kind of big annual events with companies coming in for recruitment, and also to kind of just explore what women are doing in computer science itself. So finally, I just need to say thank you to all of you guys for coming every week or watching the videos of me every week or whatever. And also a huge thank you to the volunteers for donating your time, both the people from NSOF today and everyone that's kind of sacrificed their Thursday evenings for the last 5 weeks. I wouldn't have been able to do it without them. So I guess like more of a round of applause to them than me. So thank you very much.